Hello everyone, I am Aloysio Dourado and I will present our domain adaptation for holistic skin detection paper. Human skin detection is the task of identifying which pixels of an image respond to the skin. Despite all advances that fully convolutional neural networks have brought for image segmentation, some common criticism is still made to argue that pixel-based approaches are more suitable for skin detection, namely, the need for large training datasets, the specificity or lack of generalization of neural nets, and prediction time. Skin segmentation approaches may be classified into two main groups, local and holistic approaches. Local approaches considers only a small area surrounding the point of interest to classify all the pixels in the image, one by one. In a pixel-based approach, the region that is used to classify each point of the image is a single pixel. Different approaches use different color spaces as input to the classification model. The classification model is usually executed several times to classify all the pixels in the original image. In patch-based approaches, a patch surrounding the pixel of interest is used to classify each point of the image. The main advantage of patch-based over pixel-based approaches is the addition of texture as information for the classification. In holistic approaches, all the image is submitted to an image segmentation model, usually a fully convolutional network, and all the pixels are classified in a single shot by the model. In addition to color and texture, holistic approaches adds contextual information that is expected to improve skin detection. Training data is usually a main concern when using deep learning approaches. There are some existing skin detection datasets. However, each one of them presents a different level of quality, illumination, and other characteristics. Besides that, each dataset presents different kinds of images, general web images, portraits, surveillance cameras, etc. The differences are so relevant that each dataset may be considered as a different domain. Training on a domain and evaluation on another dataset usually leads to poor results due to marginal probability differences of the two domains. However, one may apply domain adaptation methods to reduce undesired effects. In this paper, we evaluate the use of domain adaptation to overcome the data viability problem, using an existing large and diverse dataset to train a network to a domain with few training data. We use a 3-convolutional layer network with max pooling between convolutions and rectified linear unit activation function between inner layers to reduce the vanishing gradient effect. Due to its simplicity and performance, we used UNet as the holistic segmentation method. Our model follows the general original design, but we use a 7-level structure with addition of batch normalization between the convolutional layers. To exploit domain adaptation techniques for the problem of training data viability for skin segmentation, we evaluate 3 domain adaptation techniques. Our last approach consists in combining fine-tune and pseudo-labeling approaches in order to improve the final model performance. The in-domain results clearly show the superiority of data-centric deep learning solutions over traditional color-based approaches. Note that when using compact as source and pretipan as target, the gain of the domain adaptation approach is very expressive when compared to target-only training. Using domain adaptation from compact to SFA leads to impressive results. This observation completely refutes the criticisms of needing large datasets for training and lack of generalization power of deep neural networks. Another important aspect to be addressed is the criticism for the applicability of CNN approach for real-time applications. This is probably valid for patch-based CNN approaches, but it does not hold for our FCN holistic approach. In this work, we refuted some common criticisms regarding the use of deep convolutional networks for skin segmentation. Besides that, we proposed novel approaches for semi-supervised and unsupervised domain application applied to skin segmentation using CNN and evaluated it with an extensive set of experiments. Thank you.